I hope all of you तो जैसे कि आपने देखा है मॉड्यूल सोलर मॉड्यूल्स को सोलर सेटअप की हार्ट का जान या फिर और द हार्ट ऑफ अ सोलर सेटअप so we'll be delving more on this topic now just one more point the fact is that whenever an execution happens whenever we do a project we also in Panasonic take up EPC engineering procurement and construction पूरा end to end हम आपको execute करके देते हैं sorry पूरा एंड टू एंड हम आपको एग्जीक्यूट करके देते हैं कोई भी एक सोलर सेटअप का डिपेंडिंग ऑन द प्रोजेक्ट नीड आप एक कंपनी के मालिक हो सकते हो या आप टॉप मैनेजमेंट हो सकते हो और मे बी यू आर एंटरप्रेन्योर हु वांट्स टू सेट अप अ सोलर सिस्टम फॉर जनरेट इलेक्ट्रिसिटी एंड सेव ऑन इलेक्ट्रिसिटी तो ये जो पूरा एग्जीक्यूशन है दोस्तों इसमें काफी मेहनत लगती है और काफी केयर लिया जाता है ताकि पूरा जो ये प्रोसेस है वो सेफ रहे और काफी बराबर से काम हो एक बार सोलर सेटअप बनने के बाद यू रियली कांट गो बैक अगेन एंड अगेन तो ये जो प्रोसेस है जो प्लानिंग है वो काफी ढंग से करनी चाहिए हमारी आज इच्छा रहेगी कि हम आपको इस विषय पे थोड़ा सा नॉलेज दे सके मैं और वीडियो शेयर करूंगी Can you see my screen? किसी का म्यूट नहीं है माइक जैसा कि आपने देखा कि बहुत ही जतन के साथ और बहुत ही केयर और सेफ्टी को ध्यान में रखते हुए एक एक सोलर इंस्टॉलेशन का हम काम करते हैं तो ऑन दिस नोट इफ Murli sir Mr. Murli who heads the sales for Anchor by Panasonic solar unit if you're there I would request you to unmute and say a few words to the audience thank you Sonali is it audible yeah. Yes sir you're audible okay so first and foremost, thank everyone who has joined and supported us to promote our solar products in the past. And hope everyone is safe in the pandemic situation. There are a lot of cases also spreading. So wish everyone to be take precautionary actions to keep safe and keep healthy. Right. As everyone knows that Panasonic when we started in the solar division, we started with our distribution of JDB modules, which is our Murli sir, we can't see the video. Just for information, maybe you can then put the video off and speak. That is also okay. Are we able to put video on anyway? वो दिख नहीं रहा कुछ. Can't see anything. You can, yeah, it's fine. Is it able to see now? Not really. I think you can continue speaking. It's fine. Okay, fine. So, when we started our career in our solar division, we started with the engineering portion in terms of distribution to the modules. The companies, EPC was selling us our EPC partner, where we compared models to Jaguar. And we also did number of installations of ground mounted software companies, IT and ITS companies. Of late, we also started our module distribution, both imported as well as Indian made modules, which in the segment of body explain, monoblock, as well as the JT also. So we now promote the product ranges of DCR and non-DCR, and the body of 335 watt peak. And in the monoplug, we have got a 450 watt. And by March, we'll be getting a 545 watt range also, the monoplug modules. And in inverter segment, we have gone from 3 kilowatt to 25 kilowatt, which primarily used for our residential and the CNA projects. We are also trying to add up the higher power inverters, about 25 kilowatt to up to 200 kilowatt also. The all-in-one street light, where people would have used on a standalone street light system, where your all-in-one street light comprises of all the solar panel, the lithium carbon phosphate battery, and which usually has an earlier the VLA battery used to have in the bottom of the portion. So we have a wide range of products, and we will also keep on adding our product range in terms of residential kits in the future. So why a webinar today on which model to be procured? There are a lot of ambiguity in the market on BCD, the basic customs duty, the ALM. So there are many questions should be there in your mind and thought, which will also will be clarifying it in the webinar. And the project selection is we should also use the model the right method in the even inverter sector also, or else the whole generation will not be proper. Now, people are asking on the 540 watt range or the 600 watt. Yes, there are certain advantages or certain disadvantages. Our technical team will delve deep into it. And to make it various concerns like the high wind velocity, which can be measured high wind velocity, lesser in weight, easy for handling, and with better efficiency. So, request everyone to make use of the webinar and share your valuable insights. And we request everyone to grow together to develop a greener nation. And let's charge of the future jointly. Thank you so much, Murli sir. I think that was a very good insight from you. And now let's move on to the session. अब हम अपना main section start करते हैं. I would request Mr. Akshay, who takes care of the product management for the solar business unit here at Panasonic for us, and he would be starting the session now. Handing it over to Akshay. Thank you very much, Sunali, for this introduction, and also thank you, Murli sir, for giving the perspective of our business here at Panasonic. So I would begin by sharing my screen and second. So yes, is the screen visible? Okay. Okay. So very good afternoon, everyone. So today's topic. Okay. So before I begin, I would request everybody to please be on mute so that there's no interference between. I would definitely be taking questions. I will at the end of the session, so you may read the questions part and or even post it in the chat box also. So that as Sunali mentioned, and today's webinar is about making the right choice of the solar modules for the projects. Now, as we all know, solar in India has seen quite a long journey. It has been a market which has been growing and growing by a very good amount of pace for the past 10 to 12 years now. And there has been a consistent growth in the market which over these years. Now, before I go into that, I would probably draw your attention to this very strange slide you may call, but it is something which is related to all our lives. If you look at in every aspect of our lives, we have a lot of options to choose from. Be it your local department store, a clothing store, or different cars to be bought, or watch shows to be watched. So we are full of options everywhere.
And I think this is a story which has now become very synonymous with the solar industry also. आज सोलर की इंडस्ट्री में भी यही सेम सीन है जहाँ पे आपके पास बहुत सारे ऑप्शंस है चूज करने के लिए. And if I come to this slide where it is about solar in the Indian solar market, आज के समय में we have more than 30 brands in the industry right now. The industry has seen around more than 5 different technologies and also more than 50 different power class ratings of the modules. And जिस पेस के साथ ये इंडस्ट्री ग्रो कर रही है, every 3 months you have a new product coming into the market. So when the industry has reached such a scenario, I think as a company, Panasonic जहाँ जो खुद भी इस मार्केट में एग्जिस्ट करता है and हमारे खुद के भी प्रोडक्ट्स हैं इस मार्केट, we thought it is our responsibility that we educate our customers on how to choose the products for their projects. So that is the third way with which we thought we'll do this webinar. So going forward, I'll probably begin with talking about the overall evolution of the solar module throughout the last 10 years maybe. So if we go 10 years back, somewhere we were starting with the module solar panels were available with the ratings of in the range of 290 to 310 watt peak. And from there, it has been consistently growing. And वो consistently बढ़ते हुए हर मॉड्यूल की रेटिंग्स बढ़ती गई हैं, उसकी एफिशिएंसी इंप्रूव होती गई हैं. एंड आज के टाइम पे अगर हम बात करें, हम 310 से 440, 530, 630 वॉट पीक के मॉड्यूल्स की रेटिंग के दौर में है, जहाँ पे हमें इस रेटिंग्स के मॉड्यूल्स अवेलेबल है. क्या चेंजेस हुए हैं मॉड्यूल में, वो समझने की हमें जरूरत है. मॉड्यूल्स के अंदर क्या चेंजेस आए जिसकी वजह से हम ये वॉट पीक्स में इंक्रीज आया, पावर रेटिंग्स इंक्रीज हुई. So as you can see on the lower side, I have pointed out the different technologies. जो 310 watt peak के जो modules होते थे, वो that were based on the poly modules, polycrystalline technology. And as we move forward, then we moved from polycrystalline to polyperk technology. Perk was a technology in which helped with the better absorption of light within the modules, and hence the power generation could also increase. So this was something which was brought into the modules, and we moved from poly to polyperk, and this got us the range of somewhere around 340 to 350 watt peak modules. And but since the industry was continuously growing, and the technology was also evolving, we found that the polycrystalline modules, which were the mainstay of the industry for more than 10 years, I guess, the shift happened towards the monocrystalline technology. And that is where we started seeing ratings of somewhere around 370 and above. And in the last 3 years, the mono technology has taken over the market. The polycrystalline technology is still there, but it has almost reached a phase where it may get phased out in some time. But in terms of availability of the products, there are products which are available in the polycrystalline also. But in terms of the market dominance, if we talk, the monocrystalline technology has taken over as the dominant technology in this market. And within mono, we now have the monoperk series, and which has now got us to the ratings of 440 to 450, as well as in the higher power classes. As this progression in the wattage rating of the modules happened, there was also an increase in the cell sizes. So basically, the modules are made up of solar cells, and the solar cells have also grown up in sizes as the wattage of the modules has increased. So initially we started with the M0 cells, which was the 166 mm rating, and आज वो बढ़ के 158.75 पे पहुंचा, जो मोनो में यूज होता था. And then now in the mono per half bit modules, we are using 166 and 182 mm. cells sizes. And it is also further growing up, which is where in future it is predicted that 210 modules will also come into the market. If I talk about present times, the 166 series dominates the market right now, and the 182 is also coming into the market as a new entrant. There are few other things also which have happened. जो जिसकी वजह से ये जो वोल्टेजेस में इंक्रीज हुआ था in the overall module ratings. So the initial category of the modules were made up of full cells, but then we saw that the full cells got replaced by the half-fed cells with this power class ratings actually. So how did this help the modules in overall? The half-fed cells help to reduce the power, the current ratings, current output of the cells, and in turn help to reduce the losses which were happening in the modules. And as the losses went down, the modules would generate higher power out of them, and hence it contributed to the increase in the power class of the modules. And जैसे मैंने प्रीवियस स्लाइड में बताया कि जैसे जैसे मॉड्यूल रेटिंग्स बढ़ती जा रही थी, आपके सेल साइजेस भी बढ़ते जा रहे थे. इस वजह से जो बस बार्स होते हैं सेल के ऊपर, जो रिस्पॉन्सिबल होते हैं आपके करंट फ्लो के लिए, उनका नंबर भी बढ़ते जा रहा था. So initially the modules were made up of 5 bus bars, then we progressively moved towards 9 bus bar, and now we are also moving towards the 12 bus bar and the 16 bus bars, which are called as MPP. So this progress is also happening, and since the bus bar count increased, the collection of the current was also improved, and it also helped with the improvement in the power rating. बस बार में एक और चीज जो चेंज की गई थी वो थी शेप ऑफ द बस बार, which helped with the increase in the absorption of light, and hence in the increment in the generation of the power modules. Now, these are the changes which happened within the modules, which resulted in the growing power of the modules. So, and in other words, what I can say is that these changes helped to improve the efficiency of the modules, to overall efficiency of the modules. So now, in terms of selecting a module, which one to use, I think module efficiencies is one of the good parameters that we need to keep in mind, that how efficient are these modules. And in this slide, what I wanted to cover was that how the module efficiencies have changed when as the increment in the power classes have happened. So on the on the left hand side, what you can see is the poly technology. When the poly technologies were dominant in the market, we were somewhere around 16 to 16.5% in terms of module efficiencies. And as we made a shift towards mono and the mono-PERC series, the module efficiencies started going up. So in the 360 watt peak mono and the mono-PERC 395 watt peak, you can see the increment in efficiency which is happening because of the overall technology shift itself. But as we go forward, now in the present times, when the 450 and the 530 watt peak modules are coming into the market, we see that the overall efficiencies have not increased much. It is a tapering effect has come in, that the module efficiencies have started to saturate, and hence you see that the modules in this particular power class are almost having the same efficiencies. So the 450 watt peak module or the 540 watt or the 650 watt peak module are all in the same efficiency itself. But then the question arises, how is that these different modules have different power class ratings? What is happening within the modules that a higher power class rating is being achieved? So this is a question which we need to understand further. So this is where I would like to bring your attention to the point where we delve more into a bit of a technical parameter, maybe, where we understand that within the module, what has changed. And in this particular slide, I'm touching upon 450 and the 540 watt peak module series because we today the 450 watt peak NoPerk is the dominant module in the market, and 540 is the new entrant which is coming into the market. So we will focus on these two as of now, where we understand the difference between the. So as we move from a 450 watt peak module to a 540 watt peak module, the efficiency increase is just of 0.2%. But what you can see is that there is almost an increase of 18.5% in the overall module area. That means the dimensions of the modules have increased, and also a 18.8% increase in the weight of the modules. So basically, when the modules have moved from 450 to 540 watt peak, the modules have not gone on higher on efficiency, but the higher power class ratings have been achieved with higher dimensions, which in turn has resulted in the higher weight of the modules also. Now, this is an important criteria to be considered with regards to where we are going to use these modules. As we know, the different types of installations are there where we install modules on rooftops as well as on ground mount based projects. And this particular aspect of increased dimensions, increased weight becomes a very crucial aspect for the rooftop projects. The video which Sonali showed, I think made it very clear that what is the amount of precautions we need to take in order to executing the rooftop project. And you could see a lot of people wearing safety harnesses, being very careful with their personal safety as well as with the safety of the product also. And I think it summarizes the need of how careful we need to be for rooftop projects. And it is where a higher size module and a higher weight module becomes a challenge while executing rooftop projects. This slide is just to give you a perspective of how the module dimensions have grown up with respect to the people who are installing them on site. An average person or the average installing person, be it in your maybe within your own firms also, the installer person may be of a height of around 1.5 to 1.6 meters. But you can see that the modules of different power classes have outgrown the size of the people who are installing them. And as the sizes go further higher, the installation activity will go further difficult for rooftop projects. So this is the challenge what we see in case of rooftop, where it becomes very difficult to shift the modules onto the roof because they have become very susceptible to jerks and sagging in the module. And also the installation process becomes difficult because the person cannot reach the edges of the modules because the module sizes have grown too much. And as a result, the workers often tend to step onto the modules itself. Now, in case of the stepping of the modules, many of the installation workers are not aware and also of the damages of which can occur because of stepping on the modules. And this is the reason that people somehow miss or step on the modules and in turn damage the modules also. And but this is something, the damages can be very easily be understood and detected. What you can see here is the real image of a module where based on a person sitting or stepping onto the modules, it results in the micro cracks and the damages within the modules happen. You should keep this point in your mind that for rooftop projects, such care is taken where you are installing people, the people who are installing the modules on the roof do not step on the modules. because in terms of warranty claims, it becomes very difficult for you also, as these damages can be detected with an EL image and be a cause of concern with regards to warranty claims as well. So it is important that we choose the right product here so that the need for stepping onto the modules does not arise, and we are careful with regards to the right product for the right application. This is a video which is very easily available through NREL. NREL is a US-based laboratory which defines, which researches into solar module technologies and other renewable energy technologies as well. And they highlighted what are the problems which would arise out of people stepping onto the solar modules. There is another challenge which we foresee with regards to rooftop installations of the larger format modules, that sagging in the modules may be observed because there is no support along the longer edge of the modules. And as a result, what can be seen is that the modules may sag from the center, and which in turn can lead to micro cracks in hotspot in the future, and also to reduced performances over the lifetime. Uh, the image is of a similar module installed, and what we foresee is that the sag will result in the accumulation of say the dust in the central portion, which can be seen in the image also. But with regards to for ground mount projects, the larger format modules are very much ideal, because the concern for regards to stepping onto the modules gets eliminated. Even with regards to shifting the modules to the rooftop also becomes easy, because the shifting the modules to the rooftop is also not there. The concern with regards to the shifting is not there, as we can very easily shift the modules to the installation position of the array itself. So the person need not get onto the modules to install it, and the workers can do the installation from the ground level itself. So this is something which becomes a very easy aspect to handle with regards to ground mount installations, and the person can also handle the large format modules easily. Another thing that we need to keep in mind is with regards to the system losses which can occur in the system, as well as the compatibility with the inverters that we are using for the project. So if we compare the current outputs of the monoPERC module, the 450 monoPERC module versus a 540 watt peak module, there's almost a 20% increase in the current value. Now, you might know that the higher the current, it leads to the higher the losses inside the modules, and also to an increased operating temperature of the modules. So the higher temperature is the ones which result in higher losses within the modules, and this is a systemic loss which happens within the modules itself. And if the modules get subjected to, say, a persistent shadow on a rooftop, it can lead to an enhanced rate of hotspot generation as well. Now, because as we see that there is almost a 20% increase in the current output, the cables which you're using, the 4 square mm cables which you will be using, that will also see a 40% increase in the DC losses for similar string lengths actually. So this is a loss which you need to take into consideration while selecting the modules also. And I think for the rooftop projects where the space for ventilation of air from the backside of the modules is very less, the higher current peak modules, higher current output modules, that is the 540 modules, will see a higher temperature losses also. And with regards to the inverters which are being available in the market today, they are the technology in the string inverters has not evolved as fast as the modules have been growing. The modules are constantly increasing their power outputs, and hence the current value is also growing up. But the string inverters have not seen that technology improvement. And today also there are a lot of inverters in the market which do not have the capacity to meet the current requirements of the higher power output modules. So we need to be careful and from that perspective also. Another point is with regards to the wind resistance capability of the modules. I think this is one of the very crucial factors in India because India has been seeing a consistent increase in the number of cyclones which are happening over the years. On the left hand side, what you can see is a history of few recent cyclones which have come up, and the recorded wind speed, the maximum wind speed during those cyclones have surpassed expectations throughout, and hence it becomes important that the projects that we are installing, the structures that we are using, and the modules as much as possible. The 540 watt peak modules, because of their larger frames, are more susceptible to these higher wind speed pressures, since they have because of their larger size, and hence the present models which are available in the market are only designed up to a wind speed to withstand wind pressures of up to 2400 pascals, whereas the monoper 450 watt models are low fluxes can withstand a pressure of up to 34 joules. So there is the 140% higher wind resistance capability for the 450 watt peak modules as compared to the 540 watt peak module. So wind resistance also is a very important factor to be considered by choosing the product for your project. And with regards to rooftop projects, this becomes an important criteria because as you go higher with respect to the ground, the wind resistances, wind speed pressures grow exponentially. So that is an important factor to be considered, especially for the rooftop projects, and where we see that 450 becomes an ideal fit for rooftop projects in such scenarios. With the 540 watt peak modules coming into the picture recently, the major advantage which is claimed is that there is a significant the BOS cost saving in the projects that we're installing with 540 watt peak modules. So so we also delved into that to understand how much is the advantage that we see. And what we understood was that for the rooftop projects with metal sheet, where metal sheet projects are there, the savings are in the range of around 0.2 to 0.3. Whereas similarly for RCC projects, the savings were in the range of almost 0.9, 0.8 to 0.9. So with regards to savings also, the clear differential can be seen between rooftop and ground mount projects. And because the savings are not significant for the rooftop projects, I think it is better to go with a product which can help to sustain higher wind resistances, help with lower systemic losses, and be more compatible with your inverters. Which is where we feel that 450 comes out as a clear ideal solution for a rooftop project, whereas a 540 watt peak module becomes much more suitable for applicability in the ground mount projects. So, considering all these factors in the mind, I think it is very important that we ask ourselves that how are we choosing the modules for our projects? Does bigger the better holds true for all the project types? And is the BOS savings really significant enough that risk module damages during rooftop installations. So this was a question that we also asked ourselves because we are into this field and we also have our own products in the market, and we felt that it was important for ourselves also to identify that our own product will be suitable for which application type, and that is where we came up with an understanding module that we have brought into the market is more suitable for rooftop applications, whereas the newer module which we are bringing into the market, the 530 and the 540 watt peak module, will be more suited for the ground mount based projects. And that is why as the new year comes in, we are also bringing the large format modules, the 530 and the 550 watt peak module, which we would want to pitch for to our customers who are doing projects in ground mount conditions. So that would be a fit for them. And we're also bringing in a lower dimension module as compared to the 480 to 495 watt peak modules for the residential and the commercial rooftop projects, so that this will be a newer addition after the present 450 watt peak module phases out. So this is how we are also going to be present with our product offerings in the market and be going to provide the product options to our customers. So this brings me to the end of my presentation, and I hope that I have given you some idea with regards to what factors to be considered for choosing the product for your own projects. And from our side, we wanted to make a genuine effort in educating our customers that on the right applicability of a particular model of the product. From our side, Panasonic will continuously be available in terms of bringing new products, new technologies to the market. And as you can see, in terms of our product offerings also, we are there as where the market is. We have the latest products which are coming into the market, and we are also introducing them into the Indian market so as to support our customers. So this is from my end. Thank you so much. And I would hand over to Somali for any further questions.
Thank you so much, Akshay. That was very informative, and I hope all of you could and can take back some pointers from today's webinar. Of course, your topic is very vast. It might take another session or two for you to completely grasp the technicalities. It's almost like for example, whenever there is an end output, the ingredients are very important. So unless you plan the ingredients well, your final output might not really be as you desired. So कोई भी प्रोजेक्ट एग्जीक्यूट करने से पहले काफी प्लानिंग, काफी डिजाइनिंग करनी पड़ती है, और हमारी एक्सपर्ट टीम यहाँ पे है. Even if you need any guidance at any point of time, we are more than happy because we have subject experts here. हमारी यही कामना रहेगी कि जो भी प्रोजेक्ट्स आप एग्जीक्यूट करो वो एक प्रॉपर प्लानिंग के साथ हो, और suitability of modules and inverters are more important than like Akshay said, it's not that bigger is better. It's just about what suits your project and what is the application that you need. So with this, we come to the end of Akshay's session. We are open for any questions. आपको मैं रिक्वेस्ट करूंगी कि आप चैट पे भी अपने क्वेश्चंस लिखें, अपने सवाल पूछें.
Hello, ma'am. Can you hear me? Hello? Hello?
Yeah.
I am Nitin Murli. I want to understand what is the difference technically between HIT and monopole. Because monopole half-cut cells which you have give similar kind of outputs. Lower current, higher voltages. But the pricing is twice that of monopole. Of HIT.
Sure. Yeah, Akshay will definitely try and answer this query.
Hello, madam.
Sanjay ji, let's do one thing. Akshay, would you want to answer that first?
Yeah.
So, Sanjay ji, ये answer के बाद हम आपका question लेते हैं.
Right, madam. No
yeah, thank you.
Mr. Bode, the technology is the difference is between how the cells are between HIT as well as monopoc. In terms of HIT cells, there is an additional layering of the cells which are used within the module in itself, which in turn results in the lower degradation and lower temperature coefficients of the modules. So, as a result of which, over the lifetime of the project, the degradation which happens within the HIT modules is significantly lower as compared to a monopoc modules, and that is where the price premiumness comes in for the HIT module, and which is why the modules are priced at a higher price as compared to the monopoc. Monopoc was a technology which gained prominence in, say, last 4 to 5 years. HIT was something which got implemented quite long back by Panasonic and had been present for quite some time now. So this is where the difference comes in terms of the majorly what is there, that the overall degradation which happens within the modules and the lower temperature coefficients, which in turn results in better performance of HIT modules.
Can I intervene? Because the warranty period of both is the same, 25 years performance warranty. Then if the duration would have been so low, then it should have been 40 years of warranty for the same duration of say around 85% at 25 years.
Sir, with regards to warranties, it is a very standard perspective that we have taken with regards to the industry. Generally, we say that it is the warranties are there for around 25 years, and which is something which is very consistent throughout the industry also. We have not tried to deviate from the industry norm there, but we are assuring you the performance of the modules, the generation of the modules, which follow the lower degradation of our HIT. So that is what we are assuring. But in terms of warranties, we have followed the norms which are existing throughout the industry.
So what is the duration of the panels?
So the overall duration for HIT panels is somewhere around 0.26% year on year.
All right. Thank you so much. I hope this answers the questions. We are also available offline for any detailed discussion on the topic. Please feel free to reach out to us anytime. I also have a question which talks about how do I become a channel partner? Yes, we do have a criteria. We do have a qualification system. I would request you to mail your background and company profile to the solar ID that has been provided on the chat, and we'll get back to you. Actually, the question that says, what will be the generation difference between 540 and 450 for the same capacity solar panel? Would you want to take that?
Yes. In terms of the technology behind 450 and the 540 watt peak module, the cells are the only difference is in between the cells of the cell size. So the overall technology remains the same. So if we are going to calculate the say per watt peak generation of the modules, they will be almost similar to each other. We will not find any major difference between the two, because overall the cell technology remains the same, and the per watt peak generation will come out to be similar. How to select voltage of panels for megawatt scale projects, 1500 volt system? What needs to be considered for the available capacity of inverters? So with regards to voltage range, as you might know, for some time back, the voltage ranges used to be, the system voltage range used to be around 1000 volts, whereas now it has shifted towards 1500 volts. the, uh, uh, the the shift majorly happened because in order to reduce the number of strings which need to be formed on the DC side. So now with a 1500 volt system, you can connect more modules in series, and hence the lesser number of strings will be required, and hence you can lower down on the cable requirements also. So that is where the modules, in order to implement this change, the modules got designed up to 1500 volts, 1500 volts, and the inverters which are being used are also now have started coming in the range of 1100 to 1500 volts. So when you're connecting the modules to the inverters, you just need to ensure that the inverters, your the string voltages are in line with the rated input voltage of the inverters on the DC side. So that is the one care that you need to take care of.
Okay, I can see Mr. Sanjay Gupta had raised his hand, and Mr. Raja, I think one of you can unmute and ask a question.
Madam, good evening. This is Sanjay Gupta. First of all, I want to give thanks for sharing good technical information among us. We have two questions, madam. Panasonic has its own manufacturing facility in India, or they purchase the solar panel from Vikram or other than that? First thing. The second thing, if we want to install a purlin on shade, is there any method other than painting or repeating?
Sonali, I like this question. Murli.
Yes, Murli sir.
Yeah. See, as for the manufacturing is concerned in India, we have got a tie-up with the OEM factories present in India. We have got one in South and one in the Western region. We are also looking seriously to identify one more in North. Apart from that, we have got our own manufacturing facility of HID models in Malaysia. Then we have got a OEM factory in China.
Thank you.
And it's any purlin on the purlin we have to install on shade other than and puncturing or pasting. Is there any latest technology involved?
Need not to puncture it. Right now, there are so many solutions available. Like Lloyd has got their own paste, TM has got it out. No need of puncturing the sheets. The GA sheets are the thin sheets. Need not be punctured. We can apply the paste and then we can do it out.
Pasting is sustainable. No wind pressure.
Yeah, we have used it. We have used in the projects.
Right, sir. Thank you.
Thank you, Sanjay. And thank you for your positive feedback as well. We look forward to your support for the future webinars as well. Any other questions from Mr. Raja? Right? Can you please unmute? Thank you, sir.
Yeah, I just want to know which is the best panel suitable for Indian conditions, because in India, I think North, South, East, West have their own climatic conditions. So how do you explain or what do we tell our customers for Indian conditions?
So say the modules which are designed. So the modules are designed not specifically saying for the Indian conditions, but when the testing of the modules are done, they are done as per the IEC standards. Now, IEC standards has much more rigorous testing conditions with regards to temperature and humidity and the operating conditions of the modules. So, that is where, based on these testings, we decide whether the product is suitable for a particular market or not. Now, it is just not for India. This is a very standard norm which is followed across the world. And with the same conditions also, the same modules can be used for, say, in Middle Eastern market, or which is very hot, or very in tropical climates also, say in the Southeast Asia, which is where it is very humid, and as compared to India, or even in Siberia also, which is very cold, which is so the IEC test conditions ensure that the product is suitable for all these conditions.
Is the degradation varying from place more monopark.
As the technology has evolved, the degradation rates have reduced. So, as I had mentioned, that we began this industry by using polycrystalline technology, but we have now moved on to monomer technology. So, as the technology has improved, the degradation rates have also reduced, and which is where we see that our present monoperk modules are with a degradation rate of around 0.55%, where the earlier modules used to be in the range of 0.7 to 0.75%. So there has been a consistent reduction and improvement in the degradation rate of the modules.
Thank you.
Thank you so much, Akshay. Thank you, sir. There is a question. I think, Murli sir, if you are around, you can take this up. How do you ensure that channel partners execute the quality jobs, and how do we go about ensuring the final project execution?
So from Panasonic, we are only a module partner here for the channel partners and system integrators. Of course, we are not living there. We are also about a back-end state support, which I think Bhushan should be there in the team. We could do that. We are on the generated DDC support, we are support them in for designing. So the project is going to be shared upfront to us. We can even work to them closely, and it should be confidential with our team. Since we are also doing EPC, it will not be shared to them also. So we take that responsibility to ensure to give a good quality material in terms of designing and in terms of support also. From our end. We did in the past, and we are also there to support you. And any inputs if you got to do a better designing, our team can support us.
Okay, thank you, sir. We have 5-10 minutes more. A lot of you have raised your hands. Please unmute and let's see if we can answer that.
Yes, Sodali, this is Surinder Reddy calling from Hyderabad.
Hello, Surinder ji.
Yeah, very good informative and the good presentation, Ajay and Murli Krishna Garu. My Murli Krishna Garu, recent government order MNRE GO says that from 1st April onwards, all modules should be indigenous who are using for the rooftops, net metering. How to address that Indian indigenous and Indian modules for rooftop under net metering scheme? I think you are aware of the GO, no, Murli Krishna Garu?
Very much aware, sir. Very much aware on the back of the R also. See, two major things. One on the BCD part. This is all majorly done by the Indian manufacturers. Hope everyone is aware of it. One is to promote the Indian manufacturers. The government of India is imposing on 40% BCD for the module and 30% the silicon cell. Second thing is the ALM has been there for the past 2 years and still not being implemented. We are thinking that it may be postponed, but for the ALM to be there for manufacturers, our OEM partners are well registered with the ALM. So it's only like what we do in co-licensing with our BAS and IEC. We are also working on it to give it out. And there are many OEMs in India, not only us. There are many OEMs.
Is there any plan registering ALM under Anchor Panasonic or OEM will be the front end?
We are working on it, sir. We are giving our representation to the MNRE, and we will get it shortly. And it will be like the module manufacturer, original equipment manufacturer will have the ALM, and we will be doing the co-licensing with them as we did for the BAS and IEC. Similar procedure will be done, and we will come with the clarity before the
couple of weeks.
Before April 1st. Yes.
Yeah, because the time is very short. February, March.
Hello. Yes, sir.
Hello. Do you think it is postponed?
So we are having a strong put that it will be postponed, sir. That's what we are going to do.
Yeah, because there are many important manufacturers out there. So
particularly they are putting in, see, if you see the manufacturers which has been done on Chinese model manufacturers, the BAS takes almost roughly 3 to 5 months also. Whereas the Indian model manufacturer, if you want to do a co-licensing, it already takes 1 month. So it is indirectly putting a pressure not to promote the Chinese plant. Yes, as you rightly said, there are many Taiwan manufacturers, and this industry will not grow with only the Indian model manufacturer. There should be a Chinese intervention of the imported models to be there. And the developers already got their approval with the imported ones. They got exemption for the BCD as well as for the ALM project developers. So for the net metering projects also, people support and then work on to it. Yes, it is going to be a serious impact. The models are going to be imported and kept in
a lot of importers have been done, imported the models also. There is a very less inflow of the models from Chinese.
Thank you, sir. Okay, we'll take one last question. Do we have plan?
Good evening, madam.
Yes, certainly.
I am Padmaraja from Chennai. I would like to ask one technical question. In terms of solar module degradation, the performance, graph validation, many of the customers, end users are asking to verify. Is there any simple way to do this?
So, sir, you are talking about the degradation portion?
Yeah, degradation. You are showing the 25 years performance guarantee, correct? The graph.
Yes.
The customers are, the end users are asking us to validate and verify like this. Is there any simple method to do this?
Sir, it is basically done through from considering the design of the project itself. For any project that you are designing, you have to take into consideration certain losses which happen in the system, and you are calculating that based on those losses, what would be the energy made out of a plant. And in our in-house projects that we are doing, what we do is that basis these losses estimations, we tell the customer that considering a certain irradiation being available at the site, this is the energy output that you will get out of your project. And since we define that what is the yearly degradation in the modules, we can also give an estimation in terms of what will be the subsequent generations year on year. And in the projects which are under our O&M, that is operation and maintenance under our own teams, we have been showing consistent result in terms of the generation being received out of the plant. So since the